Today we are going to focus on fundamental unit and derived unit. But before the fundamental unit and derived unit, at least we must have an idea of measurement, units, physical quantity, and then we'll be able to understand the fundamental and derived unit. That's why I want to start with measurement. Measurement is the comparison of an unknown quantity with the standard and recognized quantity. Whenever we have to measure something, just for example, if we are in grocery and we want 1 kilogram of sugar, then let's say shopkeeper takes a beam balance, and if he put a piece of brick in one of the side and start to measure sugar, then we will not recognize this because the piece of brick may or may not be 1 kilogram. That's why we will search for a standard recognized mass which is made up of iron. So measurement is the comparison of an unknown quantity with a standard and recognized quantity. Okay, now next, what is physical quantity exactly? All the measurable quantities that can be measured directly or indirectly are called physical quantity. For example, length, mass, pressure, force, current, etc. all are physical quantities. When we measure the physical quantity, just for example, if we measure the length of the room and it is found 12 feet. If we measure rice in the grocery shop and if it is 5 kilogram, then we'll write like this. Wherever we measure something, then we have to express that measurement, and a measured quantity is always expressed in terms of a number with a unit. Without the unit, it doesn't exist. Only 12 doesn't mean anything. But when feet is attached with it, and if kilogram is attached with it, then we can understand that this is the length and this is the mass. This way, a measured quantity is always expressed in terms of number along with unit after the measurement. Okay, this is about the physical quantity. Now, I want to talk about the unit. What is unit? Units are the standard and recognized quantities that are used to measure unknown quantity. For example, meter is a recognized quantity, standard quantity, kilogram, second, etc. are some example of unit. These units are previously established and they are recognized. And so, units are the standard and recognized quantities that are used to measure unknown quantities. Now, I want to tell you about this different system of measurement. Do you know that there are different systems of measurement, and some of them are very famous system of measurement? We have to understand about them, and we are still using these systems. These famous systems are: number 1, MKS system; second, CGS system; third, FPS system; and fourth, SI system. These are the famous system of measurement and are used all over the world. In different countries, different systems are used. Okay, I want to tell you about them one by one. What is MKS system? It is one of the system of measurement in which the unit of length, mass, and time are taken as meter, kilogram, and second respectively. Inside bracket I have taken their symbol also. Okay, this is the MKS system, means meter, kilogram, and second system. There's another system, CGS system. What it means? It's very simple. It is one of the system of measurement in which the unit of length, mass, and time are taken as centimeter, gram, and second respectively, and their short form is cm, g, and s. And another system, FPS system. What is it? It is one of the system of measurement in which the unit of length, mass, and time are taken as foot, pound, and second respectively. In America, this pound is widely used. If you ask with American what is your weight, then you will say that my weight is 160 pound or 170 pound, something like this. I mean to say, he is used to with just the pound, not with the kilogram. We have to understand ourselves that 1 kilogram is 2.2 pound. Okay, let's go forward. SI system. SI system is widely used all over the world in scientific measurement. Actually, this system is established to bring uniformity in the scientific measurement. So, we can define this way: it is an internationally recognized system of measurement established in 1960 by the International Convention of Scientists held in France to bring the uniformity in the measurement all over the world. Just remember, it was established in 1960 and it is established by the scientists in France to bring uniformity in the scientific measurement all over the world. The units assigned by SI system is called SI units. We can say internationally recognized units of measurement established in 1960 by the International Convention of Scientists held in the France are called SI units. This is our target. I mean to say we are using SI units in the scientific measurement. Okay, there are 7 fundamental units in SI system of unit. But before this, I want to present one question. What is it? Why is SI system of measurement known as enlarged and modified version of MKS system? Actually, SI system is enlarged and modified version of MKS system. The reason is very simple. SI system contains all the 3 fundamental units of MKS system, that is meter, kilogram and second. Moreover, it contains other 4 fundamental units also to measure all the physical quantities used in the study of science. So it is called a modified and enlarged version of MKS system. Actually, 7 fundamental units are taken to measure all the physical quantities which are used in the scientific measurement. Let's go forward. If you are told to write advantages of SI system, we can say 2 advantages. It contains 7 fundamental units, so it can measure all the physical quantities used in science, because previously it was just 3 only in different system. And second, it is international system of measurement which is used all over the world, and because of this reason the people of different countries can make business transaction with each other and can express the physical quantity to each other. Okay, now let's go forward. What is fundamental physical quantity? Physical quantity can be divided into 2 types. One is fundamental, another is derived. Fundamental physical quantity, what it means? Independent physical quantities which does not depend on the other physical quantities are called fundamental physical quantities. For example, length, mass, time, temperature, etc. Length cannot be derived from mass. It cannot be broken down into temperature or time or mass. In the same way, mass cannot be broken down into time. These are the fundamental physical quantities: length, mass, time, temperature, etc. But another derived physical quantity means physical quantities which are made by the other physical quantities are called derived physical quantities. For example, velocity, force, work, acceleration, etc. Velocity is derived from the physical quantity length and time, and force is derived from the physical quantities mass, length, time. So these are derived physical quantities which are made by using other quantities. Okay, what is fundamental unit? Now we are talking about the major part. What is fundamental unit? Unit, not quantity. Units which are independent of any other unit but other units can be derived from them are known as fundamental units. Just remember this. They are independent and cannot be derived from other, but other units can be made by using these units. For example, the unit of length, mass and time, that is meter, kilogram, second, hour, gram, etc. are fundamental units. Now let's talk about one question. Why is meter known as fundamental unit? If you are told to write why it is fundamental unit, then you can say this way: the unit meter is independent unit. It can neither be changed nor be related to any other unit. Since an independent unit that cannot be derived from other units and cannot be changed or related to other units is called fundamental units, therefore it is called a fundamental unit. The same can be asked like this also: why kilogram is known as fundamental unit? You can reply in the same way. Okay, now let's go to next. What is derived unit? Units which are made by using fundamental units or which can be expressed in terms of fundamental units are known as derived units. For example, the unit of velocity, acceleration, force, etc. are derived units. The question is, why the unit of pressure known as derived unit? If you are asked why meter is fundamental unit, it can also be asked that why unit of pressure known as derived unit. We can say this way: SI unit of pressure is Pascal. All of we know that is Newton per square meter, and PA equal to Newton per square meter. If it is expanded, means Newton is expanded to kg meter per second square, and meter square is same. And here we have meter square in denominator and there is meter in numerator. This meter of numerator can be cancelled with one of the meter of denominator. Then we'll have just 1 meter in denominator. So kg remains same. This meter is cut down and this meter is now only 1. That's why meter to the power minus 1 is written, and second to the power minus 2 is present. And that's why what can we say looking at all these are fundamental units. Thus Pascal is made by the fundamental units kilogram, second and meter, kilogram, second and meter. Since a unit expressed in terms of fundamental unit is called derived unit, so the unit of pressure is derived unit. Okay, now let's talk about the fundamental units. How many fundamental units are used in the scientific measurement? We have to remember each of them with their symbol. So I want to present fundamental unit according to SI system. There are 7 which can be represented by a table, and this is serial number, physical quantity, which physical quantity is measured by which unit, and what is the symbol of that unit. The serial number 1, let's say length. Length is one of the physical quantity. It is measured in meter according to SI system. Its symbol is small m. Let's remember small m. Mass is measured in kilogram. Its symbol is kg, small k, small g. Number 3, time. Time is measured in second. Its symbol is small s. And temperature is measured not in degree Celsius, it is measured in Kelvin, and its symbol is K according to SI system. But this K is capital. Why capital letter is used as symbol? If the unit of any physical quantity is taken in the name of the scientist, then it is denoted by capital letter. Okay, number 5, luminous intensity. It is measured in candela and its symbol is CD. And 6th, electric current. Its unit is ampere and it is taken in the name of the scientist Ampere, so its symbol is capital A. And the 7th one, amount of substance. Amount of substance is measured in mole and its symbol is MOL. These are 7 fundamental unit according to SI system. Now I want to put on some question, and if you can answer this, better. Otherwise I will answer the question. Which one of the following option represents fundamental unit of mass of matter, amount of substance, luminous intensity of light, and temperature of matter respectively? Now the options are G, MOL, CD and K. GM, MOL, CD and degree Celsius, KM, MOL, J and degree Fahrenheit, and kg, MOL, CD and J. Now it will be better to go through question instead of going through these options. We'll feel a little comfortable with the question. Which one of the following option represents fundamental unit of mass of matter? Mass of matter. Look at this, 1, 2, 3, 4. G is gram. Okay, mass. GM is wrong symbol for gram. That's why we have to drop it down. This is okay. KM, kilometer. This is meter, not the unit of mass. That's why we have to drop it down to number 2 and 3 is dropped. Now we have only 1 and 4. 4 is kg, kilogram. Yes, there may be 1 or maybe 4. But 2 and 3 is not correct. Now second Second physical quantity. First physical quantity is mass of matter. Second is amount of substance. Amount of substance is measured in mole. That's why in first and fourth, both of them have mole. That's why both of them exist. Now third is luminous intensity. Third, in 1 CD represents luminous intensity. SI unit is CD, and here also CD. Both of them seems to be correct. Okay, now the next, luminous intensity of light and temperature of matter. Temperature of matter, in first case it is written K, and in last fourth one it is written joule. Joule is not the temperature, it is work done is measured in joule, but temperature is measured in Kelvin. That's why only the first option exists here, and we have to take it. Now let's go through another question also. Statement: SI system is the enlarged and modified version of MKS system. Just think about this. This statement is correct or not. And then argument 1 is written: all the units of SI system is contained in MKS system. Is this correct? Just think about this. And argument 2, 3 extra units are added on MKS system to modify it into SI system. Now, after the understanding of statement and arguments, now you have to select one of the option. Only statement is correct. Only argument 1 is correct. Statement and both the arguments are correct, and statement and argument 1 are correct. Now, which option is correct? Let's check it. Number 1, only statement is correct. Is it? SI system is the enlarged and modified version of MKS system. Yes, it is correct. MKS system contains 3 fundamental units: meter, kilogram and second. All these are contained in SI system, and moreover 4 other units are also added. That's why SI system is enlarged and modified version of MKS system. Yes. That's why only statement is correct. Seems to be correct, but only is written. Maybe other are also correct. We have to go through second option. Only argument 1 is correct. Is it? Let's see. All the units of SI system is contained in MKS system. Is it correct? No. All the units of MKS system is contained in SI system. This is just the reverse. So, argument 1 is not correct. Only argument 1 is correct. This option is not correct. This is incorrect. That's why we have to drop it down. But still, number 1 exists. Statement and both the arguments are correct. Statement is correct, previously decided. Both the arguments are correct, told, but argument 1 is incorrect. Just now we decided. That's why this option number 3 should be dropped. Now, only 1 exists till now. Now, let's talk about 4. Statement and argument 1 are correct. Is it? Look at this. Statement is correct. Argument 1 previously decided this is wrong. Till now, what exists? Just first option exists. That's why we have to tick on this. Only statement is correct. But till now, we haven't read this argument 2. Let's see, what is it? 3 extra units are added on MKS system to modify it into SI system. Is it correct? This argument 2 is incorrect, because not only 3, 4 extra units are added on MKS system. MKS system had 3 units and 4 extra are added on it, and it is enlarged and modified to form SI system. So this argument is not correct. Our correct answer is option number 1. Okay, now I want to finish this class. Today I told you about different types of measurement, what is measurement, and fundamental quantity and derived quantity, and then fundamental unit, derived unit, with some confusing questions also. Next class we'll meet with derived units.